So today we're going to talk about classifying angles by their sides and their angles. And we're going to talk about the exterior angle theorem. Okay? The triangle exterior angle theorem. So that's where we're headed. Hopefully by the end of the period you'll at least know what we're trying to learn. Before we get into this too deeply though, I want us to take a minute to do this activity. So, what I want you to do, with a ruler, I'm reading through your notes with you here, with a ruler, I want you to draw a triangle on your paper. And not this paper, you'll need another piece of paper. It can be scrap, it doesn't have to be any special, it could have writing on it, that's fine. But you have to be able to see the, you have to be able to see the triangle clearly that you're drawing. And then I want you to number the angles 1, 2, and 3. Okay? Number the angles 1, 2, and 3. Put them right down in the corner so you don't lose track of what the angle is after we do the other things with it.
Yeah, do we have to cut it out?
Yeah. Yep, you're going to have to cut it out. I'll pass it. Well, it wouldn't have to be cut. It could be torn if you tear it carefully. But before you're doing cutting or tearing, make sure you label the angles. Okay, you do have to cut the triangle out, so you do need scissors. Use most of your paper.
Wow.
So that, just do it on the back.
Oh no, what cutting?
I'm just going to put,
It's cute.
Mine's a party hat, like me on this. How do we label the angles?
and you label the angles 1, 2, and 3. Did I give you guys scissors? Okay, let me pause this. Try in your group, try to follow these directions. So we're recording again here. So I've got my angles.
That looks like a whale.
I've got my angle 1. My angle 2. And my angle 3. I gotta put it so that they share the common, common vertex and the common side. Okay? So it should look like this. And so the question is, what do they form? When we put all three of those angles together, what do you get? Louder, please. I can't hear you. Yeah, they are. Coplanar simply means they're in the same plane. They, no matter where you put them, they'll be in that plane. You're right. But I'm thinking a little deeper here. When I put those three together, what's the result? Other than I have, what'd you say? 180. 180. They make that what? This line. This yellow line right here, right? This line right here, that's what you get. When you put those three together, they add up to that yellow line. Okay? So, all three of those form a line. That leads us to this. It's called the triangle angle sum theorem. Now, did you notice that none of you made exactly the same triangle? Right? But when you put your angles together, you all got a line. And so the triangle angle sum theorem says that sum of the measures of the angles of a triangle is always 180. Doesn't matter if it's a little triangle, a big triangle, obtuse triangle, acute triangle, equilateral triangle. It doesn't matter what it is, as long as it's a triangle. The angles of that triangle always add up to 180 degrees. Okay? You pause while you finish copying it down. So moving on, classifying triangles by their angles. Okay? What's special about an obtuse triangle?
It's wide.
Let's go legs.
It's wide, got legs, hope it doesn't run away on us. That's funny, man. You gotta laugh at that.
Lol.
Yeah.
What did the one triangle say to the other?
Yes.
Cutie.
Oh, nice. Can you answer this question? What do you think is special about an obtuse triangle?
It's wider than the others. Like,
It means one angle is greater than 90 degrees. I didn't put my degree symbols on these. I don't have an easy way of making one. I usually make a little circle and then shrink it down. Then clone it a bunch of times. Go ahead and take time to do that. One angle. Do you notice that? This one angle here is labeled. It's bigger than 90, isn't it? So if the triangle is obtuse, it's bigger than 90. Again, we're classifying triangles by their angles. So if we consider that thought here, what do you think a right triangle means?
At least one side is 90 degrees.
One side,
It is 90 degrees.
Oh, one angle.
one angle. At least one angle. Can two?
Yeah.
Yeah.
Yeah? What was the rule we just learned with our little demonstration? The angles of a triangle always what?
Add up to 180.
So if angle 1 is 90 and angle 2 is 90, what would angle 3 have to be?
0.
0. Can that happen?
No.
Yeah.
No. So can two angles be 90?
No.
No. It's good. That would make it more than 180, wouldn't it? So you have to be careful there. So what do you think this says?
One angle has to be 90.
One angle is 90. One angle equals 90. Paul, you have a question?
no.
Okay. What do you think this acute triangle is?
Oh,
I know it.
less.
They're all equal 60.
No.
Just kidding.
They all equal 60?
No.
One angle is less than 90.
One angle is less than 90.
Yes.
Doesn't that mean one angle could be bigger than 90?
No.
Or one angle could equal 90? What do you want to say, Harley?
All angles are less than 90.
All angles are less than 90. That's correct. All angles less than 90. That's the only way it can be acute. And that is a cute little triangle, isn't it? Come on, Paul, you just gave that joke. You should think that's funny.
Didn't fit it differently.
Jade, what do you think equiangular means?
One angle equals 90.
One angle equals 90. We had that. That was called a what?
All equals
A right triangle.
No.
Wait.
No.
All sides
No.
are.
Wait, what about one angle equals less than 90?
One angle is less than 90.
No.
All of these have one angle less than 90, don't they?
I give up.
So it's gonna be all angles or something.
All angles are something. What do you say,
Harley?
Ariana?
Equal.
What do you mean equal?
Same.
All angles.
Same.
Just read
What is?
The
all the
angles.
angles.
All the angles. Remember what we're doing here. We're classifying triangles by their, whoa, get back there. By their angles. So we're looking at angles here, nothing else. And so what do you think is true about equiangular? Means all angles equal. Oh, I forgot my S. All angles equal. Okay?
Oh, okay, nice.
That's a pretty nice looking S, isn't it?
Yeah, sure.
Not too shabby there for an old man on the downhill slide of life.
You're not 90. You're not old yet.
You know who has turned 89 today?
Who?
My dad.
Bill
James Bond.
Wow.
James Bond turned 90 today. Not the character, Roger Moore, the actual guy who played. All right.
Excuse me.
Just kidding.
You ready, Paul? Can we move on?
Yes, we can.
Now we're going to classify triangles by their sides. So what are we looking at now to classify the triangles?
Triangles.
Their what? Their sides. So looking at their sides, what do you think scalene means?
No sides are congruent.
No sides are congruent. Nice. Or equal. Okay.
Two sides
Angelina, how are you today? You excited it's Friday?
Oh, yeah, I am.
Absolutely.
Nice.
Waiting
I
all week
feel
for
You
like-
got
this.
big plans for the weekend?
Sleeping.
Quiet, please. I'm listening to Angelina. Nick, join us, please. Angelina, any good plans for tomorrow? No? Okay, Angelina, what do you think isosceles triangle means?
One.
One
Never mind.
is a lonely
Two sides are equal.
number.
Hey.
No.
Oh, relax, man. Who am I talking to? Angelina. Just shoot something out there. We won't laugh.
Whoa.
Hey. Go ahead. All sides are equal? Hey, you shot something out there. Okay, what do you think, Catherine? I know. Don't you love it when I do that? Just shoot something out there. Angelina did. We didn't laugh. She said all sides are equal. You can either go along with that or say something of your own. They're not all equal? Okay.
Oh, you, Mr. Mitchell.
Neat Nick, what do you want to say?
They all have the same verticality.
What?
No, I know.
They all have the same verticality? Is that what you said?
Is that a word?
I don't know what that means.
It
Can I
means
Google
they're
it?
Oh, no, that can't be.
Oh.
Hey, Alexis.
I tried.
Oh, you with two fingers. What do you want to say?
Two sides are equal.
Two sides are equal. How many agree with Angelina?
No.
I do.
How many of you agree with Catherine? How many of you agree with
Jaden.
Alexis?
What about Nick you?
Do it.
Okay. Are my hands all the way up?
Yes.
But if we take those and kind of go like this with it and merge them together, we get the real rule. At least two sides are equal. At least two sides are equal. What's at least two? What numbers are at least two? Give me a number that's at least two.
Two.
Two. Give me another number
4.
less than four that's at least two.
3.
Three.
One.
How many sides does a triangle have?
Three.
Three. So it can't be four, right? Or five or six. How many angles do they have? Three.
Three.
At least two sides are equal. So if all three sides are equal, that's still an isosceles triangle. What shocking news, huh? I know it. We don't normally think of it that way, do we?
I'll just keep raising my hand.
But at least you used your deodorant one day. Catherine, what do you think?
Dang it.
All sides are equal. What do you think?
That's what I was gonna say.
That's what I was
I
going to
say
say.
no.
All three sides are equal.
Wait.
Now, wait a minute. You just said isosceles meant at least two. Could be three, right? Is that your dilemma?
Yes.
So what this means is all equilateral triangles are also isosceles triangles. They're a special case in isosceles
pause this?
triangles.
No.
Let me get the phone. Hello.
Yeah, you get the phone. I got two.
Paul, you're out of here, man.
I hope you
You're
know.
stuck.
I don't have visitors.
Okay.
Oh, what?
Nothing. I'll be back.
No,
Like at like the end of class.
she said take your things.
I know.
Okay. listen, I know it is hard to comprehend sometimes when things like this appear to be contradictory, okay? They aren't contradictory, okay? If this circle represents all triangles in the world, okay? It represents all triangles in the world. Over here we have
That reminds me of a bowl.
scalene triangles, okay? Over here we have isosceles triangles. Okay? In this isosceles triangle, all these isosceles triangles, we have another little set in here called equilaterals. Okay? Equilateral. So all of those equilateral triangles belong in that set, that bigger set of isosceles triangles. I know it's difficult to think of that way because you always have thought of isosceles as 2, equilateral 3, and there's no crossover. But the reality is there's a lot of crossover, okay? Because the definition for isosceles is not 2, it's at least 2, okay? So you'll have to try to accept that as we go through and we talk more about these. Hopefully you can learn to be okay with that, okay? Moving on. Do you agree that angle 1 is an exterior angle?
Yes.
Okay? What is some characteristics about angle 1? What do we notice is true?
Supplementary to angle 2.
Oh, nice. Nice observation. He says it's supplementary to angle 2. That means then that angles 1 and 2 form a what?
Straight
A
line.
line.
That equal.
Let me get a little highlighter here. We'll highlight that line. There we go. So, together they make that line, and that's great to know. What?
That means that if you don't have angle 2 and you have angle 1, you can find the angle 2.
Yeah, he's right. He's saying, say I know this is 70 degrees, then I can use that fact to find this one as what? 110. Good job. Now, you're looking into the future there. I love that thought process. I like it when you do that. Look into the future, think about how this might be useful. Okay? What I want to get to is the definition of an exterior angle, and we're running short of time, so I want to speed this up. One of the sides is the side of a triangle, and the other side is the extension of a second side of the triangle. And so you'll notice it together with angle 2 made this long line. So this side right here of angle 1 is an extension of this side from angle 2. Okay? And then the other side of angle 1, I shouldn't have said extension from angle 2. I meant to say extension from angle 3. And then the other side of angle 1 is the same side as angle 2 of the triangle. So that's how we're going to think of the definition of an exterior angle. And so it's got two components. One of them is sharing a side of a triangle, and the other one is sharing an extension of a side of the triangle. That's going to become important next Monday when we start working on homework on this. You're going to ask me questions, and I'm going to say, wait a minute now, what is an exterior angle? What are the two components? One that shares a side of the triangle, and the other that shares an extension of another side of the triangle. Okay? You got this all written down there, Cody? Good. Yeah. 9 o'clock, yep. Take your note in case somebody wants it. Okay, are you ready?
For what?
Move on.
Oh, yeah.
Okay. Identify all exterior angles. Megan, angle 1, is that an exterior angle? What does it take to be an exterior angle? What two components? What two components is taken to be an exterior angle? One, it has to have a what? Do you agree this is angle 1?
Yeah.
Okay? What did we just say? One component has to share a what? Louder?
I don't know if I said it.
It doesn't matter. Just talk louder so I can hear
Has
you.
to share exterior.
Has to share the same side. Is this the same side of the triangle?
Yeah.
Okay? And the second one has to do what? Its other side has to be what? An extension of another side of the triangle. Is that an extension of that other side?
Yeah.
Okay. So is angle 1 an exterior angle?
Yep.
Yes. Is angle 2? No, it isn't. Good job. Can you tell me why not? Nice. It doesn't share the same side of the triangle, doesn't it? Both of the angles here, let me go black here. Both of these angles are extensions of sides of triangles, aren't they? I said both these angles. I'm sorry, I misspoke. Both of these sides of this angle, this side is an extension of that one, and this side is an extension of that one. So it's not. So real quickly, Melody, can you tell me what are the other exterior angles of this triangle that are labeled here? We said 1 is, 2 is not. What's another one that is? 3. Another one, Hannah. 4. Yes. Another one, Emily. 6. So, yes, yes, yes. Paul, no, oh, he left. I'm sorry. Jacob, another one.
9 and 7.
9. And the last one he said was 7. So 8, 5, and 2 are not exterior angles. Okay? They're not exterior angles. You will be given pictures like this. You need to make sure you recognize that. And then remote interior angles. Make sure we write down what this says. 2 angles in a triangle that are not touching the exterior angle you're looking at. And then the theorem, the exterior angle is equal to the sum of the 2 remote interior angles. So, just to recap this, now that everybody's left, and I'll post this today. Remote interior angles, the 2 angles in a triangle that are not touching. In other words, they're not adjacent to the exterior angle. Angle 4, sorry, let me undo that. Angle 4 is adjacent to angle 1 because it shares the vertex, it shares this common side. That makes it adjacent to angle 1. Angles 2 and 3 are not adjacent to angle 1. Angle 3 shares this side with angle 1, but it doesn't share the vertex. And angle 2 doesn't share anything with angle 1 except its extension of the one side. So that makes angles 2 and 3 remote interior angles. It's only important you know that because the triangle exterior angle theorem uses the language, the vocabulary, remote interior in its wordage. And so it's saying that in this case, angle 1, this exterior angle, is equal to the sum of angles 2 and 3, which are the remote interior angles. So in words, it says an exterior angle of a triangle is equal to the sum of the 2 remote interior angles. That's always going to be true. And in this example, we have them labeled angles 1, 2, and 3. So angle 1, the exterior angle, the measure of angle 1 is equal to the measure of angle 2 plus measure of angle 3. And then we have a couple examples, and this is it for our notes. So we just learned that this exterior angle is equal to the sum of the 2 remote interior angles. Well, this one here is not a remote interior angle because it's adjacent to the exterior angle that's 75 degrees. But angle x what that rule says is that the exterior angle is equal to the sum of the two remote interior angles. So then if I subtract 21 from both sides, I get x is equal to, sorry, that's a 1, 54. Now this question here is kind of tricky because we just talked about what exterior angles were, and when we look at 100 here, it was actually 100 degrees. When we look at this 100 degrees here, is that an exterior angle? And hopefully, if you're all sitting here, you would agree it's not an exterior angle because its sides are made up of extensions from two different sides of the triangle. Okay? Now, we could use that to find this exterior angle or to find this exterior angle, and then we could apply that rule. Or we could say, what kind of angles is this one and this one? And as you think about that, sorry for that bell. As you think about that, hopefully you agree that they are called vertical angles. And the vertical angle theorem says they are always equal. So if this is 100 degrees, then that means this is 100 degrees. And then what did we just learn? The three angles of a triangle always add up to what? I'm sure you'd be yelling 180. And so we write that down. X plus 100 plus 30 equals 180. And that means we can combine these like terms. So this is x plus 130 equals 180. And then when we subtract 130 from both sides, we get 50 degrees. Okay? So, in this problem, people tend to make a mistake. And that's why I have it as an example. I don't want you to fall for it. What would be wrong, I'll do it in red because it's wrong. People have a tendency not to make this connection right here. And then instead, they say x plus 30 equals 100. And then when they subtract, they get x is equal to 70. And we'll do that because that is not correct. 100 is not an exterior angle. And so we cannot use the triangle exterior angle theorem that says these two remote interior angles add up to that exterior angle. And then use 100 for our exterior angle. We can't do that. Okay? All right. So today, actually Monday, we're going to work in class on this assignment. So have a good weekend. You don't have to do this at home. But if you took your notes, then it'll be a lot easier on Monday. You'll have a lot more time to work and get your work done. All right? Thank you. Have a good weekend.